So our first topic of the day is going to be basic math operations. So on Wednesday, we learned how to, make a main function to at least run some sort of code. We set up our environment. We did some basic string stuff, and we learned about variable types, right? Those are some stuff that we went over. Now we're going to do some actual math. So this is where kind of like the computational or the calculator part of programming comes into play. And this is stuff that we should all be familiar with. I'm assuming everyone has finished middle school math. So a plus sign is going to mean addition. So we have 10 plus 2. Minus is subtraction. An asterisk. So that's if you hold shift and click on the number 8 on your keyboard. That's the asterisk key. That's multiplication. Division is with a forward slash. Modulo is a percent symbol. And you might not have heard modulo before, but it's basically a remainder operator. So remember in elementary school, we had like a question where, for example, if we do 7 divided by 4, we get 1 with a remainder of 3. And modulo just gives you the remainder. So what do you guys think this is? I'm going to put in a modulo expression in the chat, and you guys answer of what you think the number will be after operation. Wait, that's a bad answer. No. There we go. Okay. Can you guys text in the chat what you guys think 6 modulo 4 is? 2. Okay, lower just 2. 2, 2. Yep, that's right. Okay, good. I don't think we have to do too much practice on math. We're not in math class. You probably recall that when we do exponents, we do like the little small number on the top right of another number, the base and exponent. In Java, we got to use the math library, math.pow base exp. And we're going to go into this is a method of the math object, and I'll go into detail what that means later. But just recall for now that if we go all the way back, if you were part of the class on Wednesday, you would remember that, yeah, that's right, Marco, it's 2. You remember that we have a string and we said .to uppercase. We called a method that does an operation on the string, right? In this case, we're calling math.pow, and pow is the method name, and we're giving it the base and the exponent. So what do you guys think this will evaluate to? Math.pow 2, 3. Yep, that's right. We got 8. Yeah, 2 to the power 3. Good. Then what do you guys think math.square root sqrt is? So let's do this. Cool. And what do you guys think of, I don't know if you guys have done trigonometry, but for people who know how, what's math.sin 0 or sine 0? Yeah, it's 0. That's right. What do you guys think? So now that we know that there's a math dot thing, how do you guys think we would go about doing cosine? Can someone type in like what we would sort of code for cosine? I think you guys have seen a pattern here. Right, you guys are very close. It's math.cos, or sorry, yeah, you guys are right. Math.cosine parentheses semicolon. And then there's also some constants. If you remember correctly, last class I also said that constants. Let me go back once again. Constants are values you cannot change. Like the code will literally complain if you try to change it, and we label them with all caps, right? And so the math object also comes with some handy numbers like math.pi. And you guys might be wondering what math.pi even goes to, because there is no pi symbol in coding. Let me share this specifically. There is no math symbol in there's no pi symbol in computing or in programming. So like for example, if I copy paste in a pi symbol, which right here, you will see that the code kind of complains, right? So this is not a known numerical value to Java. We have to reference the math.pi. And that also, oh, I should have to import it. Okay, cool. So math.pi is actually just a normal number. But Java already gives it to you. So in this case, it's 3.1415, blah, 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 blah. More digits than you could ever realistically use. All right. And this is where we're going to have to separate a little bit between math and computers. Because of the way how Java has types, you know how like variables, we have integer and double. Can someone say what's the difference between an integer and a double? Does anyone remember that from last class? Right? That's right, Brendan. Can someone else say what a double or float has different from an integer? Yep, that's right. So because of that, math is going to work a little bit differently. So let me go back. Actually, you know what? We can stay here. So, okay, let's do it like this. So here's a slide on division. We have integer division on the left, and we have regular division on the right. And regular division is what we're familiar with. So what is 1 divided by 2, guys? Like as a decimal. What's the value of 1 divided by 2? Yeah, that's right, 0.5. But if you see in regular division, we have a double involved, okay? And a double has decimal points. That's why we get a decimal point as an answer. But what happens when we divide 2 integers? Are we going to get a double as a result, or are we going to get an integer? This is Java, so we're going to get an integer. But the problem is, if the answer to 1 divided by 2 is 0.5, but the integer cannot have decimals, what does Java do? And the technical term for what Java does is called truncating. So truncating means basically if you truncate a number, you're getting rid of all the decimals and you're leaving all the whole digit numbers. So for example, if I were to truncate 1.25 to an, if I had a double 1.25 and I truncated it to an integer, what will it be? What will the result be? You guys can just type in the chat. Yeah, that's right, 1. And what about this number? 2.00001. What do you guys think that would be? Right, exactly. So what happens when we have 2 integers 1 over 2? Integer 1 divided by integer 2. What will the answer be? See. Yeah, that's right. Loic got it right. It's a 0. So because 1 divided by 2 becomes 0.5, but we need an integer, 0.5 will just be truncated to 0. Simple as that. And you can see, yep, left is 0, the right is 0.5. Okay. And I'm going to really quickly go back into IntelliJ here. So I'm going to just say integer a is equal to 3, integer b is equal to 5. So basically, if you have 2 integers divided by 2 integers, it's just always going to truncate it. So we're going to get another 0 here, right? And here's something very interesting. The IntelliJ will actually tell you if it's always 0. Okay, but this is a mistake I've made before in the past. I forgot to pay attention. But if you always have at least one double involved, so one of them can be an integer, you're going to get a decimal point. And you know what's even better? If you have 2 doubles, then you don't even have to worry about it. All right. So you'll often see in our code, and I might show you guys some examples of our robot code from last year, actually, just for reference. But whenever we're doing calculation heavy stuff, we always try to use double. But when we're doing stuff that's more algorithmic, like we're doing loops or something or keeping track, that's when we're going to use an integer. There are different use cases. You're going to end up using both. All right, and that's actually going to lead us to the topic of casting. All right. So let's say you had a problem where you are only given 2 integers. Okay, so I want to do a divided by b, but I don't want to get 0. I want to get a decimal point. Okay, but I am not allowed to change the variable types. So I'm going to go ahead and change my sharing back to the presentation. So this is where we're going to talk about casting. So as you can see here, we have integer a equals 1, and then we have a second variable called b, and it's a double, right? If we were to do, and in order to convert, and with the a divided by 2, you see at the end of it, we still have, we're still doing integer divided by integer, right? So we get an integer number, but we wanted to save it to a double. So we have to do parentheses and we have to say double. So you can say typecasting as, you can translate it in English as like turning into, converting units, you know, sort of like that. So let's go ahead and let's get that a really quick shot in IntelliJ. So we're gonna go ahead and run this code. All right. Just print out B. As you can see, we get a decimal point. Now, here's a very good question. How do we know which, how do we know we're converting which into a double? And what do I mean by that? So if you guys, what's like a good analogy for this? If you guys know about math and you know how we have like coefficients or exponents, you know how sometimes with an exponent, you have to be very careful if you have to add parentheses or not. For example, if you do an expression such as like 3 times 5 to the power of 2, right? Only the 5 has an exponent. The 3 does not have an exponent. If you want the whole thing to have an exponent, you have to put parentheses around and then put to the power of 2, right? I'm sure that makes sense to everybody. And so it works in the same way for casting. So in this case, for the very first one, the double is directly pointing to the A. So we're directly converting in the A to a double, and then we're dividing to 2. So for that first example on the top left, am I still sharing my, yeah, I'm still sharing my IntelliJ. Okay, for the top left one, the double is directly pointed to A. So we're gonna end up doing a double divided by an integer, which gives us a double. That's why we got a decimal point. Now let's take a look at the top right example. This time we put parentheses around the A divided by 2. So A divided by 2, well, as you know, in parentheses in math says do this first, right? Before doing other calculations, is grouping. The double is referring to the entire division. So what that means is we're gonna have an integer divided by an integer first, which will give us an integer, and then we convert it into a double. So you guys saw earlier in IntelliJ that the result of the top left is 0.5, right? It makes sense, 1 divided by 2. What do you guys think the answer would be to the top right? Because remember, we have an integer divided by an integer. If you guys can put it in the chat. Right, you're right. We're gonna get a 0. And just to prove that I'm not being stupid, we're gonna go ahead and run the code right here. And there you go. We get 0.0 because it's a double, right? We get a decimal, but in the end, we get a 0. And in much the same way, you can convert a double into an integer. But on the bottom left, we will still get a decimal. Why? Because even though we're converting A, which was originally a double, into an integer, and that also means we're dropping the decimal, we're still doing an integer divided by double, which will give us a double. So the answer is going to be 3.3333333 all the way to the end. All right. And then on the bottom right, it's the same deal. We're doing a double divided by an integer, so we're going to get a double, but then we convert it into an integer, so it's going to truncate it. So we're going to get 3. Oh, my voice cracked. 3. So any, do you guys got questions? Just go in and ask me right now. Otherwise, I'm going to move on. All right. Let me check real quick if we have any classwork for this. I think we do. All right, we got an exercise. So we are going to be coding. Haha, how fun. All right, let me just go ahead and quickly change what I'm sharing. All right, we are going to be doing an exercise. So we are going to be trying to we're going to try to convert from Celsius to Fahrenheit. All right, so the formula is given here, and I shall zoom in a little bit more just to make sure we can all see it. All right. And the equation to convert from Celsius to Fahrenheit is 9 over 5c plus 32 equals f. And we want to set c to 21, and we want to calculate f and print out the value of f, okay? And just because we haven't written any code yet, I want to make sure that we can all do it in a reasonable time, I'm going to give you guys some boilerplate code, like a template to go off of, all right? So I'm going to go ahead and give you guys an integer, okay? And I'm going to call it c, just capital C. I'm going to say 21, okay? And then at the very end, I need to calculate this integer f is equal to whatever you do here. Okay, so like do something to C. Okay, and then now we're going to do system.out.println f. So I want you guys to try to figure out how to do 9 over C plus 32. Okay, and key thing, I want decimals if possible. Okay, so I'm going to give you guys 10 minutes to do this, and then or actually let's do 5 minutes for now. Get your IntelliJ ready and start writing some code. All right, and then I'll give you guys the equation again in my IntelliJ. And when you guys are done, please, what do you call it? When you guys are done, please send it to Slack. Just like the way I showed in the beginning. Okay, well, just really quickly, let me just quickly go over. When you guys are doing division, you're doing 9 over 5. Make sure at least one of them is a double, or both of them are a double. That was a really big mistake that I saw. And even when you're doing something like C times 9 over 5, right, this looks like it should work. Algebraically, it should work, but C is an integer, 9 is an integer, you multiply them together, you get an integer. So at least make one of them a double, or you can cast it. Okay. But just keep in mind, that's something that catches a lot of people off guard. So yeah, just be careful. All right, we're going to be talking about static methods, parameters, and returns. And the most basic thing I can explain methods, like the one single sentence I would use is, it's a reusable chunk of code. It's a chunk of code you can call over and over again. Okay, and what do I mean by that? All right, what do I mean by that? So let's say I'm doing this thing, right? And I'm doing a bunch of math calculations. And I'm saying this number is this, and then I do this, right? And something that is very good practice to nail early on is to try to shorten your code or try not to copy paste too much. So if you might have noticed, for basically this chunk, I'm repeating the exact same things in lines 6 and 8, right? How can we do it so that we don't have to say system.out.println like over and over again? And if I want to change one of them, how do I change all of them? That's a method. We're going to make a chunk of code, kind of like this. This is a chunk of code, right? That you can call over and over again. Oh, geez, I'm thirsty. I'm out of water. All right. So this is a method. All right. And there's a lot in front of you right now, but we'll break it down slowly. Okay. So we're going to start on the very first line, public. Okay. And this has to do with the more overarching theme of how to program Java. But for now, actually, let's forget about the public and just think of it without it. Okay. Well, we'll go over it later in the future. And if you know already about it, cool. So first of all, we're going to say static. Static means that you don't have to do any other fancy initialization, classes, objects, stuff that we'll learn later on. You can just directly use a chunk of code. That's the easiest way to explain it. If you want to get more technical, static means it's available before initialization. Okay. And then the second number or the second term is int, and that's the return type. Okay, someone did not. It seems that I have shifted everything. Now everything is wrong. All right, let's just shift this all back then. No one has to see what happened. Okay, I did not screw up the slides. Okay, so the return type is, in this case, an integer. It means that sometimes you want to run a chunk of code and you want to get a result. For example, let's say I ask Kyle, hey Kyle, what's 5 plus 2? And he tells me, oh, it's simple, it's 7. And he has told me he gave me an answer back, and that answer was a number. So you can think of it as like a call or a question, okay? And in programming, we literally say, call this method. So I called Kyle, okay? And let's use just add one now from now on. I say, call Kyle, hey, Kyle, add 1 to 5, okay? And in this case, my 5 is my parameter. And you can see here, we also have an integer in front of the parameter name. So the parameter you can think of as a variable, and you can use that variable inside your method. So Kyle is going to think, oh, Samuel gave me a parameter. I expected a parameter, which is a number, right, of type integer, and Samuel gave me a 5. What am I going to do? I'm going to add 1. Okay, and he wants me to give him back a number that is also type integer. So that's 6. Okay. Yeah, so that's correct. So the Java version of functions are methods. Yeah, that's absolutely correct. And so, oh shoot, I did the same mistake again. Sorry, guys. Okay, well, here's the presentation. This is the add one method, static and add one integer number. Okay, and in here we do some number stuff, and then we return it. Okay. So I hope this sort of makes sense. Okay, just to make up for the fact that I screwed this over again, let's go ahead and run this code. So we are going to go back to IntelliJ. All right, delete this. So how do we use methods? So this main part is also a method by itself. It's automatically called by the compiler of JDK or whenever you run the Java program. But now we're making our own method that we're going to call by ourselves. So below this class section, okay, you see this outer set of parentheses. We're just going to make some new lines here, and we're going to define our method here. All right, so we got static, integer, add one. Okay. And then parentheses, basically saying this is a method, and we're going to be passing in an integer of type number. All right, and here we're just adding 1 to the number. Okay, we're making new variable, number plus 1, right? And we're doing system.out.println. We're going to say number plus 1 equals plus number plus 1, so we can kind of know. And then we use the return symbol here, and we return the variable or the value. Okay, now how do you actually go around doing it? So let's go ahead and make it a number. Let's call it as integer n. Okay, so now we got an integer, and to call it, we're going to say the name of the method. We're going to put in parentheses to say that we're calling the method. Parentheses specifically mean we're going to call a method, and then we're going to pass in our parameter. And what's a parameter? We're going to say n. Okay, so we pass an integer into integer. Okay, and we're going to end up with a semicolon. Now, if I go ahead and run this, you can see it says 6 plus 1 equals 7. There, the function has made the code, and I can say this over and over again, and I can put in many different numbers, right? And this is a reusable chunk of code, right? And then you can see we do a bunch of different operations, and let's just say I have to make a small tweak, or this method broke and I have to change it for every single thing that uses it. I can just change the method by itself, and everything that calls it will be affected by it. So I hope you guys can sort of start to see how methods are very useful for organizing code and making sure that when the project grows bigger and bigger, it's easier to maintain. Okay, and I'm sure that it beats printing, copy and pasting this over and over again, right? Yes, indeed you can. So because Java is not a script, you can go ahead and put it right here. In fact, we can put it in a completely different file. It really doesn't matter. Key thing though, you cannot put methods in methods. Okay, this is illegal. You can see a bunch of red stuff. Okay, that's a very good question though, Amrik. And you know what? I'll keep it up there just for the sake of it. And you might have noticed here, IntelliJ saying return value of the method is never used. Well, that's because we're returning the number that we got, and then we're not doing anything with it. So check this out. I'm gonna reassign n. Okay. So what do you guys think add 1 is gonna return? What value is n gonna be after this? Right, 7. And so if I print out n after I reassigned it, so it was originally 6. Actually, you know what? Just to make it very, very obvious. Okay. You can see we started with 6 and we ended with 7. So this is very basic of methods. Okay, so you can use it to reuse a bunch of code and whatnot. And we use it very, very often when we're writing actual Java code. We do not stuff everything into the main function. That would be against practice and result in messy code that's really hard to maintain. Make sense? And I do not have any classwork for static methods, but got some homework there. I'll just, yeah, and I'll update the homework when the class is over, and I'll update the Slack message. And we're gonna talk about comments real quick. So you know how when you guys are like writing essays and whatnot, you're taking notes, or like you have the left side and the right side column. The right side of your notes has actual information, but the left side you have like a bunch of like smaller things like questions or little tags about what this is and whatnot. Like this section is relating to economics. I don't know. In much the same way, in programming, we have that. We can attach little notes that aren't actual code. So the compiler will just ignore it. Let's take a look at what they are. So this is a multi-line. This is a multi-line document comment. It means it goes for multiple lines. We denote it with a / and 2 asterisks, and then we go on. Okay, and we often use it before the method declaration to sort of describe what the method does. Okay, so like additional information, what the parameters mean, you know. Wow, nobody put in single line comments. Okay, we're gonna go to IntelliJ. So just to give you a quick example of how we can use these multi-line comments, boom, that's a comment. Okay, you see how it's grayed out? That means the compiler is not going to process it. It's not going to break our code. And then if I press enter, you can see that it creates more asterisks, and I can put in multiple lines of comments. So for example, I can say, this is the main method where the program starts. String args is the argument. Okay, actually, you know what? Let's define our add one. Okay. This method adds 1 to a number. Integer number is the number that 1 will be added to, returns the number plus 1. Okay, so now we're able to describe it inside the code itself. So if someone else has never seen your code before, and it's like, hey, can you peer review my code? And they see a comment like, oh, okay, this makes more sense now. So it's like little notes. And then something you can do is also single line comments. So that's with 2 slashes. And you can see this does not work across multiple lines, okay? But it's very nice for when you're doing very short notes. And you can put it at the end of a line as well. So I can say here, return the number, print out what we're actually doing, set up a variable, you know? So that's a single line comment. And let's just say the most IDEs have this tool. If you want to really quickly test your code without a code, you just do control. You can hold control on your keyboard and press the / button, and it'll comment that whole thing. Okay. And just to show you that the comment doesn't work, I'm gonna run this, and it will literally do nothing. There you go. We get an empty blank line response. Okay. That's comments. All right. Do you guys have any questions, or do you guys think we can rush through if statements in like 13 minutes? All right. Actually, you know what? There's one thing that I missed. Okay. What if we didn't want to return anything? What do we do? Okay, we can't just delete it, right? It gives me an error. So I'm gonna make a new one, and we say void. Okay. And it basically means it's gonna return null or nothing. And you can actually say return null. This is perfectly allowed. Okay. But we're gonna say static void, and I say print hi. Okay. It doesn't have a parameter, and all it does is literally just say system.out.println hi. And then we can run this like any other normal function. And it doesn't return anything. Okay, it doesn't accept any parameters. It just says hi. That's what the void does. All right, let's speed run conditionals. Okay, if you guys have questions, we can go over it again tomorrow. or sorry, next Wednesday. So let me just go in and share and share. All right, we got conditionals, booleans, if else, else if switch. Okay, these are conditionals, meaning if this, then do that. So here we say x is equal to 5. Okay, is x less than 5? No. So this is a very basic simplification of how conditionals work. Okay, conditionals is just saying, is it less than? Does it match this condition? Okay, so here we have some conditional statements. You see like the greater than symbol, the less than symbol. Double equals means if the value equals each other, greater than or equal to, less than or equal to, doesn't equal, and just false. Okay, and this is where we're going to talk about the Boolean data type. All right, if you recall, Boolean is true and false, right? And just because it's so simple, I'm gonna really quickly jump into our code here. Okay, comment this out. So I have my integer n, right? If I say Boolean n is equal, Boolean bool, I think I'm allowed to do that. Yeah, I'm allowed to do that. Is if 6 is less than 8, right? We know that to be true. So if I system.out.println bool, I get true as my output, right? It's much the same way. If I say 6 is greater than 8, I said false. Now, how do we determine if two numbers are equal to each other? So for example, if I have A and B, how do I know if two numbers are equal to each other? I can't just say that A is equal to B, because remember, the single equal sign is reserved to assignment, to changing the value of a variable. So in order to compare, to get a Boolean out of it, we have to do double equals. And 6 is equal to 6, right? So that's going to return true. Cool. So I hope that makes sense to you guys. Shoot, really quickly, I'm going to show you guys what doesn't equal means. Okay. If I do doesn't equal instead of double equals, it means doesn't equal, like in English. So if they equal each other, it's false. If they don't equal each other, like 6 and 4, I guess true. Okay. And if you're confused, Google it, and there will be lots of resources to remind you. Okay. Got some logic statements as well. And, or, not. And means you have to have two Booleans that are true. So that goes into some Boolean logic. It's like a whole separate class. So what's true? True and true will become true because both of them are true. If one of them is false, then the whole thing becomes false. So and means both of them have to be true. What does or mean? Or means any of them has to be true. This or that. Okay, so true and false will equal true. What's it? False and false will equal false. You know, etc. etc. So I hope that makes sense. Oh, sorry. More simple. And just to spin your brain a little bit around, if you flip this, not also means you flip the value. Will equal. Okay, just food for thought. I'll try to assign some homework that will help you guys practice that. Okay, but it's something a little bit confusing. But you'll get the hang of it the more code you do. So yeah, the slide also explains it. Here's what I was talking about, Boolean logic. I know it's a little bit of a handful, so you guys can look over this in your own time. But either way, the way I like to memorize the easiest is and is when both of them have to be true. And or means only one of them, at least one of them has to be true. All right, what the heck do we do with Boolean statements? Why are they useful? We can do if-else statements, okay? So we can run code based on what the variables are or some sort of condition is, okay? So for example, we can say if we're doing a program, we're writing a program where what it does depends on the date. For example, if it's September, it will do this. If it's November, it's this. Okay. If it's November, if it's September, we'll say, oh, we're in early autumn. If it's November, we'll say, oh, we're in middle autumn. Okay. And you can see here, if 6 is greater than 5, which is true, it's going to run 6 is greater than 5. It's going to run the code inside if. And you can, or if you have an else statement, you can say broke may, or it'll run something else. So just to show you guys how this works, it will only run one block, but not the other. Right, and obviously 6 and 4 is greater than that. So A is going to get printed, okay? And then what if we flip it, okay? What if A is now smaller than B? The bottom one will now run. And what do we do if we want to do more than just 2? Okay, you say else if, and this is very similar like the first one, the first if. Right, so we get A is equal to B. And here's something very important to note is that technically with these two values, both this block and this block should be allowed to run, but Java only lets one of the blocks run. So whichever one is in front, we can run first. Does this sort of make sense? Can you guys like say yes or thumbs up or whatever? Like say yes or thumbs up in the chat. Okay, cool. This is the ternary operator. It's shorthand. Question mark means this is like a shorthand if. Question mark is kind of like if. If 6 is greater than 5, then it will take the first value. Else take the second value. Okay, so this is, yeah. This is a switch statement. So switch statement is a compact if statement. Okay, they have the same functionality, but a switch statement is often easier, is cleaner, especially when you have to do a bunch of different operations based on like a set number. So, sorry, excuse me. You can see here on the, am I sharing IntelliJ still? Yeah, I'm still sharing IntelliJ. This is the ternary operator. Okay, the question mark is the if. It's a shorthand. If 6 is greater than 5, then we'll take the first value or the second value. Switch statement is the same as a shorthand if. We have a switch versus an if statement on the left and the right. A switch statement, you define it with switch, parentheses, and whatever you're comparing, curly brackets, and then your cases. Okay. And default means it's basically your else. Okay. And switch is really useful when you have to like do, for example, are you still intelligent? No. Okay, we're still on slides. A switch is really useful when you have like a constant, okay, and you get passed in a constant and have to do something based on what the constant equals, or just, you know, geez, I don't know. Okay. Basically, a switch is really good for when you have to do actions that involve like less logic. So it has to just directly equal this value. So x has to equal 2, x has to equal 3. Okay. And you might notice the break statement. Break means to break out of the, break means to break out of the program execution. So what happens is if you leave out, remember correctly in the if statement, right? Only one block is allowed to run. Like even if 2 blocks conditions are met, only one of them will run, the one on top will run. if you don't have the break, it will cascade down and it will run all the other blocks, okay, down from, so if x is equal to 2, it'll run case 2, and it will run case 3, and it will run default. That's if you didn't have the break. But if you run case 2, it'll set a to hello, and it sees the break, it'll just completely exit the switch statement, and then case 3 and default won't run. So it's a very situational when you don't write break in your switches, okay? I hope this sort of makes sense. Everyone good so far? All right. Yeah. Loic. So loic acid breaks are necessary or not? They are not necessary, but you will very, very rarely see a switch statement without breaks. Okay. So that's the end of topic 8. We went through a lot today, but I will, for the next hour, I will be go look out for some questions. I'll update the Java curriculum doc, and also I will update the Slack message with them. You guys did a good job today. I think the Slack method will work well. But otherwise, it is 4 o'clock. You guys are free to go unless you guys have more questions. Cherry MX Browns. I actually have Cherry MX Browns installed on my keyboard right now, but I've lubricated them and I'm going to be replacing them with Gatheron Yellows pretty soon. I'm like going to desolder. All right. Bye-bye, Amrik.